day, a black hole came close to Earth, not tomorrow, not next year, but sometime in the distant future. Could it destroy everything we know? The universe is filled with mysteries, but among the strangest and most terrifying objects ever discovered are black holes. These things are not just powerful. They are the most extreme objects in existence. Across our galaxy alone, scientists estimate that there could be over 100 million black holes quietly drifting through space. Most of them formed when enormous stars reach the end of their lives. When a massive star runs out of fuel, gravity begins to win the battle. The star collapses inward with incredible force. The core shrinks smaller and smaller, compressing enormous amounts of mass into an unbelievably tiny region. Eventually, the star collapses so much that space itself bends inward, and that's when a black hole is born. To understand how strange this is, imagine this. Our sun is about 1.4 million kilometers wide. But if you compressed the sun enough to become a black hole, it would shrink to only about 6 kilometers across. The same mass, packed into something the size of a small city. And this extreme compression creates gravity so strong that not even light can escape it. That's why they are called black holes. Anything that crosses a certain invisible boundary around them is gone forever. This boundary has a name. Scientists call it the event horizon. Once something crosses this line, escaping becomes impossible. Not even the fastest thing in the universe, light itself, can get back out. But here's the strange part. Black holes are actually invisible. We can't see them directly. Instead, we detect them by watching how they affect nearby stars, gas, and light. Matter spiraling toward a black hole heats up to millions of degrees, glowing brightly before disappearing forever. Ironically, the darkest objects in the universe are often surrounded by the brightest light, and some of these monsters are enormous. At the center of our galaxy sits a supermassive black hole known as Sagittarius A. It contains the mass of over 4 million suns. Fortunately, it's about 26,000 light-years away from Earth, which means we're safe. At least for now. But what would actually happen if something or someone got too close? What if a black hole suddenly appeared near Earth? Would we be instantly destroyed, or would something even stranger happen? Because the real horror of black holes isn't just their gravity, it's what they do to space, time, and you. And once you start falling toward one, there is no turning back. But before we fall into one ourselves, we need to understand how close a black hole would need to be to destroy Earth. And the answer is terrifying. Because the distance might be much smaller than you think. At first, you might imagine that a black hole would need to be extremely close to Earth to destroy us. But surprisingly, that's not entirely true. Even a tiny black hole could be devastating if it appeared nearby. Imagine something no bigger than a grain of sand. Now give it the mass of a mountain. That's the kind of density we're dealing with. Black holes are incredibly compact. Their mass is squeezed so tightly that the gravitational pull around them becomes unbelievably intense. If a small black hole suddenly appeared somewhere within our solar system, it could begin disturbing the delicate gravitational balance that keeps everything in orbit. Planets could shift, asteroids could be pulled from their paths, even the Earth's orbit around the sun might slowly begin to change, but things get much worse the closer you get. If Earth drifted toward a black hole, the side of our planet closest to it would feel a stronger gravitational pull than the far side. This difference in gravity is called tidal force, and tidal forces near black holes are extreme. At first, oceans would begin rising and shifting dramatically. Earthquakes could shake the planet. Volcanoes might erupt more frequently. But as the distance shrinks, the forces become catastrophic. The entire planet would start stretching. Our atmosphere would begin leaking into space, slowly being pulled toward the black hole. Then massive chunks of the Earth's crust could begin tearing apart, mountains collapsing, continents breaking. And if the Earth fell into orbit around the black hole instead of falling directly in, something even stranger would happen. The constant stretching and squeezing of the planet would create enormous friction inside Earth's core. This process is called tidal heating. The interior of the planet would heat up dramatically. Within a short time, Earth could transform into a world of endless earthquakes, volcanic eruptions, and colossal tsunamis. A literal planet-wide disaster. And this would only be the beginning. Because if the Earth kept moving closer, gravity itself would begin pulling everything apart. Not just the planet, but every single object on it, including you. Scientists have a name for this horrifying process: They call it spaghettification. And the name might sound funny, but the reality is anything but. Because if you ever got close enough to a black hole, your body would slowly begin stretching into something that looks exactly like spaghetti. But how exactly does that happen? And could anyone survive crossing the event horizon? The answer depends on one surprising detail about black holes. If you somehow survived all the chaos and found yourself falling toward a black hole, brace yourself. This is where reality starts to get really strange. Near the black hole, the difference in gravity between your feet and your head would stretch your body. Imagine standing on a trampoline while someone yanks the edge upward, except on a scale billions of times worse. Scientists call this horrifying effect spaghettification. For smaller black holes, spaghettification starts long before you even reach the event horizon, tearing apart anything in its path, rocks, planets, even you. Your body would elongate vertically, compressed horizontally, until it becomes a thin stream of atoms. Not a pretty picture. Supermassive black holes, on the other hand, are a bit more forgiving. Due to their enormous size, the gravity at the event horizon is almost uniform. In theory, you could cross the event horizon without feeling immediate stretching. But don't celebrate yet, your destination is still the singularity and nothing can survive there. The event horizon is a point of no return. Step past it and the black hole takes over completely. Light itself cannot escape, which is why black holes appear pitch black. From the outside, an observer would never actually see you pass the event horizon. They'd watch you slow down, fade, and turn red as time seems to freeze for you. Inside, though, things get even stranger. Space and time behave in bizarre ways. Forward is always toward the singularity, and no matter which way you move, you are inevitably pulled inward. Trying to fight it is pointless, your only option do nothing. But here's the mind-bending twist. Some physicists, inspired by Stephen Hawking, suggest that black holes might not completely erase information. The atoms and energy that make up you could leave subtle imprints, potentially hinting at alternate realities where you didn't fall in. The universe in this sense might be more like a choose-your-own-adventure story than a fixed path, but while you're inside, it would feel like absolute doom. And that's just part of the black hole journey. Next, we'll dive deeper into the singularity itself, the point where space, time, and physics break down completely, and where the mysteries of the universe get truly mind-boggling. Because at the singularity, reality itself doesn't behave the way we think it should. At the heart of every black hole lies the singularity, a point of infinite density, zero volume, and unimaginable gravity. Here, the rules of physics as we know them simply collapse. Space bends, time warps, and the very concept of up or forward loses meaning. Anything that reaches the singularity is compressed into something smaller than an atom, a point with no size, no memory, no return. Even the strongest materials, even light itself, are powerless. Planets, stars, and matter from entire galaxies that fall in are crushed and absorbed. In this sense, black holes act as the ultimate equalizers. Everything ends up the same at the singularity, distinguished only by mass, spin, and electric charge. But some black holes spin. Rotating black holes twist space itself, forming a ring-shaped singularity. Surrounding it is the ergosphere, a region where standing still is impossible. Space literally drags you along like a whirlpool, forcing you to orbit, rotate, and move, whether you want to or not. If you survive until this point, the idea of time becomes meaningless. Inside the event horizon, past, present, and future blur. In a sense, black holes are not just cosmic vacuum cleaners, they are time machines, reality warpers, and mystery generators all at once. The singularity also hints at a larger cosmic puzzle. Some physicists believe black holes could connect to other universes, potentially acting as gateways. This remains purely theoretical, but it's a tantalizing possibility. And as terrifying as this sounds, black holes are not eternal. Thanks to Hawking radiation, they slowly lose mass over unimaginable timescales. For a black hole the size of our sun, it would take 1067 years to evaporate. Supermassive black holes last even longer, outliving almost everything else in the cosmos. Yet even in their death, black holes leave behind enigmas that could redefine our understanding of the universe. And if you think surviving the singularity was impossible, the endgame is even stranger. After surviving the journey past the event horizon, stretching, spaghettification, and the singularity, what happens next? The black hole slowly radiates away its mass through Hawking radiation. Particles escape, energy is released, and eventually, after unimaginable eons, the black hole disappears completely, leaving nothing but radiation behind. The matter and information that fell in, its ultimate fate remains one of the greatest mysteries of physics. Some theorists argue that information is preserved in alternate realities. Others suggest it might be encoded on the black hole's surface in a holographic way. The truth is, no one knows for sure. Black holes challenge everything we understand about space, time, and matter. But even with all this danger, black holes are a source of astonishing cosmic wonder. They shape galaxies, influence star formation, and provide a glimpse into physics at its most extreme. And while the idea of falling into one is terrifying, studying black holes allows humans to explore the very limits of reality, where gravity, time, and space intersect in mind-bending ways. One day, perhaps we'll fully understand what lies beyond the event horizon. Until then, black holes remain the ultimate mystery of the universe, both destructive and fascinating, deadly yet captivating. So the next time you look up at the night sky, remember, somewhere out there these invisible titans are waiting. And in their darkness, the universe keeps its deepest secrets. Do you dare to imagine what it would be like to fall in and see the universe vanish? Thanks for watching. See you to the next video.